Hi, Math Analysis. This is Ms. Kaiser, and I'm going to teach you today the last lesson in Chapter 9, 9.4. I will have sent you an email already, and hopefully you read it, about what we're going to do for distance learning. So everything's going to be connected to the spreadsheet. So as you used the link on the spreadsheet on School Loop to log on to this video. All the worksheets are there to be able to print up, and all the answers are there. So this week we're going to learn complex numbers in polar form, and then you're going to work on your review sheet. We were supposed to have a test on Thursday, so I will need to figure out what's going to happen with that. And then we were supposed to start a new chapter on the following Monday. I also will have to keep you posted on that. But for now, let's learn the last section of notes so we can work on our last section of homework and our review sheet. So complex numbers in the polar form. If you remember from Algebra 2, I equals the square root of negative 1, and I squared equals negative 1. And I cubed would equal, as you can see, I wrote up there, I squared times I, which is negative 1 times I, which would be negative I. And then I to the fourth is I squared times I squared, which gives you positive 1. So when you're simplifying negative roots, you can use this concept here. You cannot leave an answer with I as to any power larger than 1, and you can't leave a negative in a square root. So if you're looking at example 1a and you're simplifying those, you want to factor out the negative 1 and factor out the 16 and 3 so we can simplify the radical. And then the square root of 16 we know is 4. And then, as we were reminded, the square root of negative 1 is I. So your answer is 4I root 3. For B, it's I to the 27th. So what you want to do there is you want to find the number that's divisible by 4. So any I to any power divisible by 4 is always 1. So I to the 4th is 1, I to the 8th is 1, I to the 12th is 1, I to the 16th is 1, and so on. So the largest number that goes into 27 is 24. So you can write that as I to the 24th times I to the 3rd. And as you look above, you can see I to the 3rd is negative I. And like I said, I to the 24th is 1. So your answer would be negative I. Now for C, you have to be very careful here. You cannot multiply negative roots together. So what you need to do is simplify out the negative first. So never multiply negative roots together. So we've got to factor out my I. So the square root of negative 64 is 8I, because the square root of negative 1 is I, and the square root of 64 is 8. So what would be the square root of negative 36? Take a moment to think about that, and hopefully you got 6I. And then when you multiply them together, you multiply the 8 and the 6 together to give you 48, and the I and the I together to give you I squared. But as you see above, can't leave an I squared in, but we know I squared is negative 1. So 48 times negative 1 is negative 48. All right, so a complex number is the sum of a real and an imaginary number. So a complex number Z is A plus BI. So when you look at the complex plane, the real part is the x-axis, and the imaginary part is the y-axis. So the axis represents the real part A, and the y-axis represents the imaginary imaginary part bi. So if I were to graph 4 plus 3i, I were to graph the ordered pair 4, 3i, then I'm going to take and connect array from the origin to that point. So if I were to do -2, -2i, that's the one in blue. And then I graph array from the origin to that point. So that's how I graph those numbers. So, complex numbers in polar form. So to convert a complex number into polar form, you are going to use this theorem. So as you look at this right triangle here, we know that the sine of theta equals the opposite leg over the hypotenuse. So the sine of theta equals b over r. And then you can isolate b to get b equals r sine theta. And then, as you can see, right here, that a equals r cosine theta. So your complex number is r cosine theta plus I r sine theta. And if you factor out the r, you can put it in front. As you can see, I underlined r parenthesis cosine theta plus I sine theta. And then there's an abbreviation for that. It's r cis theta. That stands for cosine theta plus I sine theta. So you can condense it into that. So when I multiply polar coordinate complex numbers together, I multiply the r's together, but I add the thetas. So this is simple here. When I'm multiplying z1 times z2, I'm just going to multiply the 3 and the 2 together. And then I'm going to add the 154 plus the 370. And that is them multiplied together. If I wanted to write it as a complex number, I would expand it, so not in its abbreviated form. I'd expand it to 6 cosine 181 plus 6i 181. Then I would take my calculator and find the cosine of 181 times 6 and the sine of 181 times 6. And that is the complex number in rectangular form. So one's polar form and one's rectangular form. So I might be asking you, okay, multiply these together and then give me the answer in both forms. So that's how you would give me the answer in both forms. So you'd need your calculator for this. But if the angle was on the unit circle, you wouldn't need the calculator. So if that angle was 180 instead of 181, or if it was 120 or 150 or something on the unit circle, and you will probably have that type of on the no calculator section, and one you have to use your calculator on the calculator section. All right, let's take a look at reciprocals of complex numbers. Reciprocals of z would be 1 over z. And what you do there is you take 1 over r, and then you take the negative of theta. So find the reciprocal of this would just be 1/2 times cis negative 154. Okay? Now quotients are you divide the r's, but you subtract the thetas. So if you want to find the quotient here, I'm going to divide the 6 and the 3 to get 2, and then I'm going to subtract 54 minus 67. So my angle will be negative here. So I could write it as negative 13, which is clockwise around Or I could find the positive value. So if I asked you to put theta between 0 and 360, you would want to add 360 to negative 113 to get the 347. So those both answers mean the same thing. Okay. And if I wanted to write it in rectangular form, I would do the same thing. I would expand and use my calculator. All right, so De Moivre's theorem used to raise a complex number to a power, usually finding a root. So z to the n power, usually the n is a fraction because you're finding a root. So it'd be z to the 1/4, which is the fourth root, or z to the 1/2, which is the square root. In this problem, it says find the cube root of that. Well, to find the cube root, it's z to the 1/3. So when you're finding the cube root, you want to find all possible answers between 0 and 360. Or 0 and 2 pi, depending on what is used, radians or degrees. So n is 1/3 there. So we're going to take r and raise it to the 1/3 power. Then we're going to take 120 and multiply it by 1/3. And then we're going to take 360n and also multiply that by 1/3. So you're going to get 2 because the cube root of 8 is 2. And then 120 plus 1/3 is 40 plus 120n. So now what you're going to do is give me all possible answers between 0 and 360. So when n is 0, theta is just 40. When n is 1, you have to add 40 and 120. When n is 2, you have to add 40 and 240. And then you're not going to get any more because the next one, if I added 120 to 280, it would be over 360. So usually you get 3 cube roots, 4 fourth roots, and so on. Okay? All right, we're going to try another problem like this. I believe you already have this typed on your note sheet, but I, for some reason, don't, so I'm writing it down. So I want to find the 6th root of negative 1. So you can see, first I want to put it into its polar form. So it's negative 1 plus 0i. So the first step is to convert it to polar form. So we can look at the picture that I drew to the right by plotting the point, and we don't even need to do much work to find the angle. We can see it's 180. And then if you square negative 1, you get 1. If you square 0, you get 0, and you add them together and take the square root, because that's how you find r. It turns out to be 1. So I want to find z to the 1/6. So I'm going to take 1, raise it to the 1/6. Then take 180, multiply it by 1/6, 360n multiplied by 1/6. So the 6th root of 1 is just 1. So I've got 30 plus 60n. So here, what I'm going to have is I'm going to have 6 answers. So one answer is just when I plug in 0 for n. So that one's just 30. Now I'm going to add 60 to 30, and I'm going to get 90. Then I'm going to add another 60 to 90, and I'm going to get 150. Then I'm going to add another 60 to 150 and get 210. Add another 60 to 210 and get 270, and get our last answer, which is 330. And then I'm going to hit 360. So I'm going to stop there because I want it to be 0 to 360, not including 360. So those are the notes for 9-4. You can work on the worksheet. You can print it up. If for some reason you don't have a printer, then you can write it neatly on graph paper and look at the problems on your Chromebook. Again, I hope you're staying healthy and and I will post another video when needed. And I also will post a video going over the worksheet a little bit, the review sheet a little bit with you, some more challenging problems. And I'm not sure, but if there is a pickup that needs to be done for students, I'm not sure what's going to happen. I will be able to have you guys pick up graphing calculators if you don't have them. Anyway, thank you and have a great day.